If a rocket launch is like a beautiful dance performance, then the launch tower is the stage on which this glorious spectacle takes place. And for the dance to be perfect and safe, we need a sturdy stage, and SpaceX has excelled at providing just that. They've developed large launch towers, continuously improved their performance over time, and it's even cost-effective. This completely humiliated NASA's scientists and its mobile launch tower. And why's that? What problems is NASA facing with its own launch tower? All will be revealed in today's episode of Alpha Tech. But hey, check this out. Before we get into the main content, we want to let you know, thanks so much for supporting our channel these last 3 years. Right now, we got over 86,000 subscribers, very close to the 100,000 mark. And to achieve this, we do need your help. So please, if you're watching this right now, hit that subscribe button so you won't miss out on any of our exciting content. And it also keeps us motivated to make these videos for you every day. All right, let's continue. Okay, so recently, rocket enthusiasts are likely immersed in a lot of hot news, from the Boeing Starliner disaster to the upcoming Starship flight and SpaceX's drama with the FAA. But let's not forget that right at Starbase, there's a massive engineering project worth noting, arguably the tallest ever, that is steadily progressing. It's none other than Starship's OLIT 3, also known as the second launch tower at Starbase. Foundation got laid on June 13th, and to date, it has reached the 7th segment of the tower assembly. In reality, stacking the tower could have probably been quicker, as the first 6 segments of the tower demonstrated SpaceX's impressive speed. The construction of the launch towers proceeded at a remarkable pace. After completing a solid base with piles, steel plates, concrete, and foundations, the company began installing the OLIT 3 modules at a dizzying speed. July 11th marked an important milestone when the first module was placed on the base. Just 5 days later, on July 16th, the second module got stacked, and continuing this pace, the third and fourth modules were installed on July 18th and 25th. Particularly impressive was the installation of the last 2 modules. Just a week after the fourth got done, the fifth module was neatly placed into position August 2nd, and only 2 days later, on the 4th, the sixth module also got fully installed. On average, SpaceX took less than 4 days to complete the assembly of each tower segment. That is an insane speed, far surpassing their previous efforts and setting a new standard in the space industry for the speed of constructing rocket launch infrastructure. However, on the other hand, it took SpaceX up to 12 days to begin and complete the stacking of the 7th tower segment. So, what caused this rapid pace to get interrupted? As we know, SpaceX is currently using the DMAG CC-8801 to stack the pre-assembled modules for their newest Starship launch and landing tower in Boca Chica. A few days ago, the crane was lowered for extension, adding new parts to the boom, main boom, and jib. On August 9th, the extension work was completed, and the crane was raised with the upper part of the boom resting on a replacement support. While being raised, the backstop hydraulic cylinders, which are supposed to retract as the boom's raised, seemed to have locked and then tore free of their mounts as the pressure built. SpaceX proceeded to repair and reconfigure the crane. The result was admirable. The crane got back in operation, towering magnificently across the Starbase sky. To be honest, this was just a minor setback in SpaceX's construction process, and we shouldn't worry too much, as the pace of work will surely recover in the near future. New work at the launch tower will soon prove this, and we can expect progress at the new launch pad in the near future. Yes, you heard that right. It's a new launch pad. Of course, it's not just a launch tower being built, as it's simply one part of the overall structure. 2 weeks ago, we got an announcement from SpaceX that they plan to extend the launch pad area, including adding new water and fuel tanks to support 2 launch pads. A map released by the FAA has shown us some of SpaceX's plans for expanding the orbital pad B. Although the new design indicates that the current orbital pad will look very different from the proposed version, it still aligns with what we expect from SpaceX. They're also constructing a flame trench, and a space engineer posted a simulation on X of how this project might look once completed. None other than the space engineer. Thanks to him for making these awesome renderings. Surely the end result's going to be something awesome that we all look forward to. But let's wait and see. But what's equally exciting is when the launch tower actually becomes operational. With the distinction between a catching tower and a launch tower, similar to the proposed application before the FAA in Florida, the exact roles of the 2 launch towers in Boca Chica, Texas, remains a big question mark. Let us know your thoughts down there in the comments. Okay, everything that SpaceX has done and is doing truly leaves NASA's scientists in awe compared to what they've developed for NASA's missions. Yes, it's exactly what I'm talking about, the mobile launch tower, the system that serves to launch NASA's vehicles in the Artemis missions. The first version, Mobile Launcher 1 ML1, was built in 2009 as part of Constellation's program. After the above program was canceled, it was developed into a system to launch SLS Block 1. The total time from its appearance, conversion to completion was about 10 years, with an estimated cost of about $1 billion. Until November 2022, ML1 was used in Artemis 1 mission. After that mission, ML1 got damaged and had to be repaired in time for Artemis 2 mission with a crewed flight. That's all NASA has got after more than a decade with a ton of funding. Even more disappointing, it will apparently only be used 2 more times with Artemis 2 and 3. From Artemis 4, the SLS Block 1B version is going to be used. It'll require a taller and heavier launch tower. That's why NASA has developed a new mobile launch tower system. The second tower, ML2, was designed by this agency to serve the launch of SLS Block 1B and Block 2 of the Artemis 4 missions. It was planned in 2019 and construction started the following year. The main contractor to build ML2 is Bechtel. Initial construction work on ML2 was expected to be done by early last year. The initial cost for the construction of ML2 was $383 million. However, to date, the initial deadline has passed, and Bechtel has not yet completed the construction of ML2. Rising costs and delays have prompted NASA's Office of Inspector General to investigate. And surprisingly, the investigation showed that the total cost has reached $960 million. That's 2.5 times the initial estimate. Along with increased costs, Bechtel's launch tower handover to NASA has been delayed until October 2025, more than 2 years behind the original contract. Even many audits showed that Bechtel may not meet that deadline. Bechtel explained the delay and increased costs due to the impact of COVID-19, as well as an increase in prices. But the cause is considered to come from both sides. NASA rushed to give the contract to Bechtel before the ML2 system specs were finalized. As for Bechtel, they underestimated the scale and complexity of this project. That leads to subjectivity and ineffective operations, leading to delays and increased costs like we just talked about. Thus, it probably took them another half a decade or more to complete their second mobile launch tower. If last year's investigation cost nearly $1 billion, how high is the total cost going to be when everything's all said and done? Some people will say the pandemic's greatly affected the work of NASA and its contractors. However, that reason's not really convincing. Take a look at SpaceX. Around the same time, they developed a new launch system, the Mechazilla system, and OLM. From OLM's first concrete piles in July 2020, and by the end of 2021, OLM and the launch tower were basically completed. This shows that the more reasons NASA and Bechtel give, the more their ineffective operations get exposed. However, in any case, it's clear that catching Starship is still a challenge for SpaceX's launch towers. The company has dramatically complicated the process of testing early Super Heavy and Starship recovery and thus reuse by fully removing traditional and predictable landing legs and designing its latest prototypes such that the only way they can be recovered in one piece is with a giant mechanized launch tower. For a booster or Starship catch, the rocket approaches the tower, enters the gap between the splayed arms, hovers in place while the arms close around it, and eventually comes to rest on hard points that appear to offer about as much surface area as a coffee table. Based on a simulation of the process shown by Elon, calling it a catch is a misnomer, as the arms basically move in one dimension. They open and close and can't actually grab the rocket in any real sense. As built and shown, they're closer to a tiny fixed landing platform capable of minor last-second positional adjustments. Eventually, chopsticks could have a small amount of time off of post-recovery processing, removing the need for a crane or the same arms to attach to a landed booster or ship. They could also shave off the dry mass required for landing legs, though all interplanetary ships are still going to need legs. However, they will also inherently make proving their own efficiency a nightmare. By all appearances, the current recovery mechanisms on the arms and the landing hardpoints on the ships and boosters mean that a catch could fail if either stage is more than a foot or two off from a perfect bullseye or rotated a few degrees in the wrong direction. With the method SpaceX has devised, even the tiniest error could easily end with a massive, pressurized, partially fueled rocket destroying the chopsticks and dropping a few hundred feet to the ground, guaranteeing an explosion that could damage surrounding infrastructure or start fires. In the event of larger anomalies during a landing attempt, Starship or Super Heavy could accidentally impact the launch tower, damaging or even outright destroying the skyscraper-sized structure. We really don't hope it hits the tower. Yeah, exactly. And especially not that launch ring, which is really hard to make. So that launch ring is quite complicated. Ultimately, the immense risk posed by any catch attempt means that unless SpaceX has miraculously gotten the design of everything involved nearly perfect on its first try, the company will have to be extraordinarily cautious and expend a large number of ships and boosters to avoid rendering its only Starship launch tower unusable. At least to some extent, SpaceX likely knows this, and Super Heavy would likely need to be in excellent health and perform perfectly during the ascent and boost back portions of its launch debut to be cleared for a catch attempt. Ultimately, Starship's first orbital launch could end up being even more of a spectacle than it's already guaranteed to be. Finally, we have to wonder what made Elon decide to act so recklessly. Understandably, the payoff on a bet like this is incredibly huge. If the tower can catch the rocket and move it back into position on the launch pad, that could help SpaceX reuse their rockets faster than ever. The highest turnaround time for a Falcon 9 booster from the previous flight to reflight is 27 days. In March of 2020, Musk said that he wanted Starship to be able to fly 3 times a day. This will be one of the most ambitious features of a spaceflight project, already breaking new ground. If Elon wants to build a city on Mars by 2050, he might come to depend on that rapid turnaround time. In 2019, he estimated that the city would require around 1 million tons of cargo to reach self-sufficient status. If each ship carries 100 tons, that means SpaceX will need to make 10,000 flights over the next 30 years, or around 333 a year. That's it for today's episode. Thanks for watching and see you next time.